Hi friends, Dr. Lewis here. Today we're going to be going over this standard, which is 4th grade geometry. A, because it's the first of the geometry standards, and 2, because it's the second of the first of the geometry standards. So part of this standard is meeting this learning target. I can analyze and classify triangles based on side length, angle measure, or both. And so that's exactly what we're going to do today, friends. So a triangle, you can see examples of these triangles here, and you probably already know the definition of a triangle, but a triangle is a two-dimensional or flat shape with 3 sides. So I'm going to write a two-dimensional shape with 3 sides. Now that's the big marker of a triangle. It has those 3 sides. I'm going to underline it 3 times. 1, 2, 3. There are 3 sides in all triangles. Okay? So what we're going to do today, friends, is we're going to start to analyze what triangles look like based on their angles and their sides, and we're going to classify them. So when we're classifying things, we like to put them into groups. So I'm going to show you one way that we can do this. Okay, we're going to use a T-chart. And so we're going to classify triangles. Oops. And we're going to classify those triangles based on their angles and their sides. All right. So in Zearn, the first 2 lessons this week are all about triangles. One lesson is all about using the sides to classify the triangles. The other lesson is all about using the angles to classify those triangles. So this video is a twofer. You get the lesson help for both the first 2 lessons in Zearn this week. Okay, so let's start with angles, something we're already really familiar with. Okay, so as you recall, angles are measured in degrees. We measure angles in degrees. That means it's just the unit of measure it's a unit used to measure the size of angles. Okay, 1 degree is equal to 1/360th of a full rotation, and we remember that 360 is a full turn, so getting back to the beginning. So 1 degree is 1 fraction of that full rotation. So we see these are different sizes of angles. I bet you could name each one of those angles right now because you have already done so much work with angles. Remember, it's the figure formed by 2 rays or line segments that share an endpoint. And triangles have 3 of those endpoints. So they have a line segment here shared with this endpoint, another line segment here shared with this endpoint, and then this line segment here, it shares this endpoint and this endpoint. So that's where the angles are in triangles. Boop, boop, boop. You probably remember from our work last week that an acute angle is an angle with a measure greater than 0 but less than 90. So it's less than 90. Now an acute angle, a great way to recognize that if you don't have a protractor, is to compare it to a right angle. A right angle has exactly 90 degrees. So an acute angle will be less than a right angle. So let's look at those together and kind of compare those. So you can see the acute angles are kind of closer together than the right angles. That brings us to obtuse angles. Obtuse angles are a measure greater than 90 and less than 180. So it's not quite a flat line, a straight angle, which is 180 degrees, but it's greater than 90. So let's look at those and compare those to the right angles as well. You can see they're wider and spread further apart than these right angles. So acute angles, right angles, and obtuse angles, what do those have to do with triangles? Well, if a triangle has one acute angle, it is called an acute triangle. So an acute triangle it has one acute angle. So I'm going to edit this a little bit because that is not correct. I was thinking of another angle. And that will come up in just a second. So forget that I said one. I should have said all three are acute angles. All three are acute angles. I'll say that one more time. All three are acute angles. So that would look like this. I would draw a triangle that does not have a right angle or an obtuse angle. So that would look like this. All three of these angles are less than 90 degrees. So this would be an acute angle. And again, I apologize for that mistake a moment ago. Not just one, but all three are acute angles. All three angles are acute angles. All three angles are less than 90 degrees. So that's how you get an acute triangle. All three angles are less than 90 degrees. Let's talk about the next one, a right triangle. So this is where you'll probably see why I made the mistake that I made a moment ago, is because a right triangle looks like this. A right triangle has one right angle. A right triangle has one right angle. So I'm going to write what I wrote before, one right angle. And right triangles have, of course, a right angle, so it's exactly 90 degrees. So those look like this. I could draw a right angle, but then I connect these two just like that. And I know it's a right triangle because, boom, that's exactly 90 degrees. And then these two angles, of course, are acute. And that's why we don't call this an acute angle, because it has one right angle, and we do call this one an acute angle because all three are right. So that's a big difference. All three are right, or acute here. All three are acute, and two of these are acute, but one is right. So it takes the name of a right triangle. All right, and then finally, you probably guessed what the last one is called because of your knowledge of angles already, but the last angle classified by, or the last triangle classified by its angles is called an obtuse triangle. Now, an obtuse triangle has one obtuse angle. It only has one angle that's greater than 90 degrees. And when you're drawing an obtuse triangle, one thing that I tend to do is I tend to go beyond straight up and down, like beyond that perpendicular right here, because that means that it'll be greater than 90. So I might come over here and draw an obtuse angle. I know this is greater than 90. And then again, I just connect these 2 points right here. And again, look, this creates two acute angles here and here. So we know this is an obtuse triangle because it has one obtuse angle, and that's greater than 90 degrees. So triangles are classified by their angles, acute, right, and obtuse, but they're also classified by their sides. And remember, a triangle, of course, has 3 sides and 3 angles. I'm gonna just write that. It has 3 angles. It also has 3 sides. That 3 is our magic number when it comes to triangles. And of course, you probably remember that tri means 3. So tri means 3. So triangles, not only are they classified by their angles, they're classified by their sides. And so we're going to talk about those different types of triangles right now. The first way we classify triangles by their sides is with equilateral triangles. Now, I want you to look at these triangles real quick, and I want you to look at the word equilateral, and I want you to think what that probably means. An equilateral triangle is a triangle with all sides the same length. All sides the same length. Now, this isn't about the angles, this is about the sides. So, equilateral, remember, equal means same, and it's an equilateral triangle. We're categorizing it or classifying it by its sides. So it's a triangle with all 3 sides the same length. So, because I am lucky enough to have graph paper, I'm going to draw an equilateral triangle using the squares on my graph paper to make it all 3 sides the same length as best as I possibly can without using a ruler. So I'm going to start here, and I'm going to go 1 box, 2 boxes, okay? 1 box this way, 2 boxes this way, and that means I can go half here. And a good way to recognize if it's an equilateral triangle, if you don't have a ruler, in Zearn this week, you'll see these markers. So if you see a mark here and here, that means these 2 sides are the same. So if you see a third marker here, that means all 3 of these are the same length. Now remember, I'm not measuring it perfectly. I'm just doing my best with graph paper. So if you had a ruler, you could probably do way better than I could at measuring the sides of this triangle. But an equilateral triangle is a triangle with all 3 sides the same length. That is what an equilateral triangle is. So let's talk about the next classification of triangles based on its sides. It's the isosceles triangle. Now, one way to recognize if triangles are equilateral or isosceles is by lines of symmetry. An equilateral triangle will have lots of lines of symmetry. It'll have lines of symmetry this way. It'll also have lines of symmetry this way. It'll also have lines of symmetry this way. An isosceles triangle is a little bit different because it only has 1 line of symmetry. And that is because an isosceles triangle is a triangle with exactly 2 congruent or equal sides. So I'm going to write that down here. Isosceles triangle is a triangle with exactly, no more, no less, 2 congruent or same length sides. So here are some examples of some isosceles triangles, and you can see that they have only 1 line of symmetry, and it's this way, right down the middle this way. I can't go from here to here because it won't be equal on both sides. But if I were to go down this way, you could see that has a line of symmetry here, and here, and here, and here, and here. So, isosceles triangle, tried my best to draw a really good one. I'm gonna make it a little thin. So an isosceles triangle, these two sides are congruent, but this one is much thinner. So I'm not going to draw a matching line right here. And that means that it only has one line of symmetry right there. There's that line of symmetry. Okay? Yeah. All right. So that leaves us with the third and final way to classify triangles based on their sides, and that is a scalene triangle. A scalene triangle is different from equilateral and isosceles because look at these triangles. What do you notice? It's a triangle whose sides are all different lengths. So a scalene triangle has this side is longer than this side, is longer than this side, or shorter. No sides are the same, so you won't see any lines matching on a scalene triangle. That also means you won't have any lines of symmetry because they're all completely different sides. So a scalene triangle is a triangle with three different side lengths. Awesome. And so that would look something like this. Maybe I have one over here that's this long, I have one over here that's this long, and then I have another one over here that's this long, and none of those are the same length. Now, you can classify angles using, or classify triangles using just their angles, just their sides, or both. This week in Zearn, you're going to be asked to recognize, is this triangle acute, right, obtuse? And is this triangle equilateral, isosceles, or scalene? So it can be an acute isosceles triangle, right? It can be a right isosceles triangle. It might be an obtuse scalene triangle. It really just depends on the triangle that you're looking at. So looking at this one, what do you notice? This one is a right scalene triangle. This one is a right scalene triangle. This is an obtuse scalene triangle. This one is an acute scalene triangle. All right, let's look at this one. In isosceles triangles, we have, I'm looking at this one. This one looks like an acute isosceles triangle, another acute isosceles triangle, yet again, another acute isosceles triangle. This one is also an acute isosceles triangle. This one is an obtuse isosceles triangle. And then looking at my equilateral triangles, what do you notice here? It looks to me like all of these triangles are equilateral and also acute. Really interesting combinations. So this week when you're exploring that, I want you to think about triangles. What are their angles and what are their sides? And that's how you can give those triangles their names. That's how you can classify or sort those triangles. So friends, I wish you luck this week. I cannot wait to see what you are able to accomplish this week working with triangles, and I hope that you have a wonderful rest of your day. Bye.